Hi, in this video we are going to discuss different concepts of acids and bases. All we know that acids are sour and bases are bitter, acids are corrosive and bases are slippery. But today we are not just memorizing definition, we are going deeper from simple concept of acid base to what really makes one acid stronger than other. One just adds flavor to food, the other can burn skin. Once you understand that, you will feel like a real chemist and you would not just guess, you will crack it confidently. Let us start from the origin, the Arrhenius concept. According to Arrhenius concept, acid is a substance that contains hydrogen and produces hydrogen ion in aqueous solution. And bases are the substance that contains hydroxyl group and produce hydroxyl ion in aqueous solution. Acids actually produce hydronium ion in water. Arrhenius published his concept in 1884 in his PhD thesis and people rejected it. And in 1903 he won the Nobel Prize in Chemistry. According to modern statement of Arrhenius concept, an acid is a substance that, when dissolved in water, increases the concentration of hydrogen ion or hydronium ions. And a base is a substance that, when dissolved in water, increases the concentration of hydroxide ions. This is because water undergoes self-ionization and produces hydronium ion and hydroxide ions. So, water already contains hydronium ion and hydroxyl ion. Acids and bases just change the concentration of hydronium ion and hydroxyl ions. In fact, all strong acids are completely ionized in water. This is because water is a good base and removes all the protons from strong acids. Even the heat of neutralization of all the strong acids is same because in water 1 mole of all the strong acid produce equal amount of the hydrogen ions. And when equal amount of the hydrogen ions and hydroxide ions combine and form water give same amount of the energy, which is almost 57 kilojoule per mole. For example, there are different acids like hydrochloric acid, sulfuric acid, and nitric acid. They are strong acid and give same heat of neutralization and same amount of the hydrogen ions in water. So we cannot differentiate their strength. This is leveling effect. Water is a very good base. It extracts all the proton from all the strong acid. So the strength of all the acid is leveled by the water. So we cannot compare the acidity or the strength of the acid by using water solvent. This is actually the drawback of Arrhenius concept. Arrhenius concept uses only aqueous medium to determine the acid and base. Anyhow, we can differentiate the acidity or strength of the acids by using the solvent which is less basic than water. That solvent is known as differentiating solvent. For example, anhydrous acetic acid is the differentiating solvent which is less basic than water. By using this solvent, we can compare the strength of the strong acids. Because in differentiating solvent, all the strong acid ionize by their strength of ionization. For example, in anhydrous acetic acid, sulfuric acid ionizes more than hydrochloric acid and hydrochloric acid ionizes more than nitric acid. This is the strength of strong acid. So we can say that by changing solvent acidity or strength of acid change. For example, hydrochloric acid in water is acid and the same hydrochloric acid in hydrogen fluoride is base. This is the limitation of Arrhenius concept. Arrhenius concept uses only aqueous medium and cannot describe those substances which do not dissolve in water. The broader concept than Arrhenius concept is the Bronsted-Lowry concept. According to Bronsted-Lowry concept, acid is a substance that can donate proton and base is a substance that can accept proton. For example, when hydrogen chloride and water react together and form hydronium ion and chloride ion. Here, hydrogen chloride donates the proton and acts as acid, and water accepts the proton and acts as a base. And when water reacts with ammonia, it forms ammonium ions and hydroxide ion. Here, water donates the proton and ammonia accepts that proton. So, water acts as acid and ammonia as base. Bronsted-Lowry introduced the term amphoteric for those substances which can act as acid as well as base. For example, water which can act as acid as well as base as we have discussed. Bronsted-Lowry concept also introduced the conjugate acid-base pair. By removal of proton from an acid, an anionic species produced which act as a base and known as conjugate base. And base accept that proton and form conjugate acid. For example, when phenol reacts with water, it gives its proton to water and form an anionic species which is known as conjugate base. And water after accepting that proton form hydronium ion which is known as conjugate acid. Conjugate base and conjugate acid determine the strength of acid and base. If the conjugate base of an acid is stable, then that acid is the stronger. So, the stability of conjugate pairs decide the strength of acid base. For example, conjugate base, which is formed by phenol, is stabilized by resonance. Here, the negative charge is not condensate but spread over the ring, which makes it less reactive and stable and make phenol more acidic than other aliphatic alcohols. Bronsted-Lowry concept also classified acid and base on the basis of number of proton that acid can donate and base can accept. Monoprotic acid, which can donate only one proton, for example acetic acid. Polyprotic acid, those acids which can donate more than one protons are known as polyprotic acid. For example, sulfuric acid and carbonic acid. Here the number of protons do not decide the strength of acids. For example, nitric acid which contains one proton is stronger than carbonic acid which contains two protons. And monoprotic bases are those bases which can accept only one proton. For example, hydrogen sulfide and bisulfate. And polyprotic bases are those bases which can accept more than one proton. For example, sulfate ion which can accept two protons. Let us know we discuss the different factors which affect the stability of conjugate base and decide the strength of acids. These factors are resonance effect, oxidation number, size, inductive effect, hydrogen bonding, and hybridization. For example, perchloric acid is the strongest acid have the perchlorate conjugate base which is stabilized by resonance. Perchlorate has 4 resonance structures in which negative charge is delocalized on 4 oxygen atom and oxygen atom is most electronegative atom. This makes negative charge on perchlorate happy and stable. Sulfuric acid gives bisulfate conjugate base which is stabilized by resonance as well. Bisulfate has 3 resonance structures in which negative charge is delocalized only on 3 oxygen atoms. This is less stable as compared to perchlorate, so sulfuric acid is less acidic as compared to perchloric acid. Bisulfate also acts as acid and gives proton. But the removal of proton from bisulfate is difficult because the negative charge on bisulfate holds the proton tightly. This is because sulfuric acid is more acidic as compared to bisulfate. Hydrochloric acid gives chloride conjugate which stabilize. There are three reasons behind its stability. First, the size of chloride ion is larger and negative charge is not condensed but spread over large area, which makes it less reactive. Second, the electronegativity of chlorine is high and it keeps the negative charge. And the third reason is the outermost shell of chloride ion is complete, which make it happy and inert like noble gases. These are the reasons behind the strong acidity of hydrochloric acid. Nitric acid gives nitrate conjugate base. Nitrate is stabilized by theory resonance structure. Sulfuric acid has also theory resonance structure, but sulfuric acid is more acidic as compared to nitric acid. There are two reasons behind this. The first, the two negative charge on nitrate ion cause repulsion and make it less stable. Second, the oxidation state also determines the stability of conjugate pairs. Nitrogen has +5 oxidation state and sulfur has +6 oxidation state in bisulfate. So these are the reasons why sulfuric acid is more acidic as compared to nitric acid. Acetic acid has acetate conjugate base which has two resonance structure, but this is less acidic like other organic acid which we use. This is because methyl group has electron donating inductive effect, which makes acetate ion less stable, so acetic acid is less acidic. Salicylic acid. After ionization, its conjugate base is stable by internal hydrogen bonding. This is more acidic as compared to its isomer like para-hydroxybenzoic acid which has intermolecular hydrogen bonding. Hybridization also play a role to determine the strength of acids. For example, acetylene has sp hybridized carbon which makes CH bond little bit polar and make more acidic proton as compared to those carbon which have sp2 hybridization and sp3 hybridization. Let us summarize this concept. Electron donating group by inductive effect decrease the acid character like we have discussed in acetic acid, but increase the basic character. For example, alkyl amine which has alkyl group which is electron donating group by inductive effect. This is more basic as compared to ammonia. And resonance or conjugation increase the acid character but decrease the basic character. For example, aniline is less basic as compared to ammonia. This is because lone pair here involved in resonance and not available for proton. So this is less basic. After all these concepts, we can say that perchloric acid is stronger than sulfuric acid. Sulfuric acid is stronger than hydrochloric acid. Hydrochloric acid is stronger than nitric acid. And nitric acid is stronger than acetic acid. Broader concept than Arrhenius concept and Bronsted-Lowry concept is the Lewis concept. According to this concept, acid is a species which can accept electron pair and act as a nucleophile, and base is a species which can donate electron pair and act as a nucleophile. And this concept involves coordination covalent bond, in which one atom donate electron pair and other accept the electron pair, and this way coordination covalent bond form. For example, in ammonia, nitrogen atom donates its electron pair to hydrogen ion. Ammonia acts as base and hydrogen ion acts as an acid. So in this way, coordinate covalent bond between nitrogen and hydrogen form. According to Lewis' concept, those atoms which have empty d orbital involve in complex formation. For example, cobalt form complex with 6 molecules of ammonia. Here cobalt is acid and 6 molecules of ammonia are bases. They are also known as ligand. When we see the electronic configuration of cobalt, we see that it has vacant orbital in d subshell, s subshell and p subshell. These vacant orbital undergoes hybridization and form 6 equivalent d2sp3 hybridized orbitals. In these 6 empty orbitals, the molecules of ammonia donate their lone pair. So these 6 molecules act as a Lewis base. Other atoms which have empty d orbital like nickel, iron, etc. also involved in complex formation. Let us now we discuss the strength of Lewis acid. There are different factors which determine the strength of Lewis acid. The first one is the oxidation state. If a cation has higher oxidation number, it is stronger than other. For example, ferric is stronger acid as compared to ferrous. When we move from top to bottom in group, acid reactor decrease. This is because size increase. And in group when we move from left to right, size decrease and acid reactor increase. And those molecules which have the multiple bond have the electronegative atoms. In those molecules, the central atom is the electrophilic center and act as acid. For example, carbon dioxide and sulfur trioxide. Here the carbon is the electrophilic center and sulfur is also electrophilic center. Those atoms in the molecule which do not have complete octet also act as acid. For example, boron in boron trifluoride and aluminum in aluminum trichloride. And other atoms of the third group are electron deficient. These atoms do not have complete octet. For example, in BF3, boron has 6 electrons. There is deficiency of 2 electrons. So this acts as acid. And the atoms of the group 6 also have the deficiency of 2 electrons, act as acid and can accept electron pair. And Lewis bases are those species which are in 9, having negative charge, for example hydroxide ion. Those molecules which have lone pair also act as Lewis bases. For example, ammonia have lone pair and act as a Lewis base. And those compounds which contain double bond also act as Lewis bases. For example, reaction of silver ion with unsaturated hydrocarbon. Here silver act as acid and unsaturated hydrocarbon act as base. These form addition product or pi complex. Other molecules like carbon monoxide also form pi complex with metals and act as a Lewis base. Another broader concept about acid-base is Usanovich concept. According to this concept, acid is a substance which can accept negative species like electron or anion, or which can donate positive species like proton or cation. And base is a substance which can donate negative species like electron or anion. Or can accept positive species like proton or cation. This is most comprehensive concept about acid and base. This definition includes all the Lewis acid and bases and all the redox reactions, which may consist of complete transfer of one or more electrons. For example, zinc react with copper ion. Zinc donates its electron pair to copper and act as a base, and copper is an acid. This is redox reaction. Thanks for watching and please comment if you have any question.